Hello friends, in today's session we will learn about diffraction in crystals. We will be deriving Bragg's law for diffraction. We know X-rays and all other electromagnetic waves interact with the electron cloud of the atoms. X-rays, since they have similar wavelength to that of the interplanar spacing of crystals, will get diffracted by the crystal structure. On this interaction of X-ray with the crystal behave like a three-dimensional grating. Just like a grating gives diffraction pattern for optical spectrum, a crystal can behave as a diffraction grating for X-rays due to their specific interplanar spacing. And the diffraction pattern that we obtain from the crystal will give us a very good idea about the crystal structure and its interplanar spacing. In this session, we will be deriving the Bragg's law for diffraction in a crystal. So here we see two beams incident on the plane, on crystal planes. The first ray is incident on the upper layer and is getting diffracted in another direction. The angle that the incident ray makes with the plane is called glancing angle. This angle theta is called glancing angle. And the beam is getting diffracted again at the glancing angle itself. Similarly, the second ray, here it is seen to be diffracted from the second plane. The second ray can also get diffracted from the first plane also, but we are considering only that part getting diffracted from the second layer. If the ray is getting diffracted from the first layer, it will be diffracted like this from here. This atom will diffract the second beam along this direction, and the first ray diffracted from here and the second ray diffracted from here. This point will not have any path difference. They have traveled the same distance and they will be in phase at the end without giving any interference. So we will be considering the rays that are diffracted at different layers here at the first and second layer. So you can see the second ray that is getting diffracted from the bottom point is traveling some extra path when compared to the first ray. First ray travels lesser path while reaching here. The second ray travels some additional path. Its length is higher. And what is the path difference between the second ray here and the first ray here on reaching this point? Both the rays started from the same place and both the rays reached the same place. But in between they travel different lengths. And what is that path difference? To find that, we should draw a perpendicular between these two rays at this point and at this point. From the initial point here, this is the starting point, up to here, both the rays 1 and 2 travel equal lengths. And from this point until the ending point here, both the rays 1 and 2 travel again the same length. This length that we see here is actually an additional length traveled by the second ray. So this is the extra path traversed by the second beam when compared to the first beam. Now we need to find the mathematical expression for this length. I will show you. We need to find the mathematical expression for the additional length that is indicated here. This length traveled by the second ray. The extra length traveled by the second ray. So now Let us try to find that extra path. Since we know this angle is theta, the glancing angle is theta, what will be this angle? Since this is perpendicular to the ray, the angle that the perpendicular makes with the ray will be 90 degree. This angle is 90 degree. And if that angle is 90 degree and the other angle is theta, obviously this angle, the angle APS will be 90 minus theta, right? So if angle APS is 90 minus theta, then what will be angle SPQ? Again, here we again see a right angle triangle here. This is again a right angle triangle. And this angle is 90 minus theta here. So again this angle will be 90 minus theta, which is theta. So we can see if the glancing angle is theta, this angle will be 90 minus theta and this angle will be theta. If angle SPQ is theta, then due to symmetry, angle QPT also will be theta. So here we have two right angle triangles, triangle SPQ and triangle PQT, whose one of the angles is theta. If this angle is theta, then what is the equation for sine theta? Sine theta is SQ divided by PQ. Here PQ is the interplanar spacing D. So I am calling this SQ divided by D, which implies SQ equal to D sine theta. So we have found the equation for the extra path. Half of the extra path traveled by the second ray, it is D sine theta. Now what is the other path? This path, due to similarity, due to symmetry, QT is also equal to D sine theta. So what is the extra path traveled by the second ray when compared to the first ray? It is 2 times D sine theta. 2D sine theta is the extra path traveled by the second ray. So that is the path difference between ray 1 and 2. 2D sine theta. So I am calling this as the term path difference. Now, from the basic principles of optics, we know that two rays will constructively interfere when the path difference delta equal to n lambda. So we have two equations for path difference. One we found from the sketch of the crystal, and the second one that we found from the basic principle of optics. So equating these two, we will get the equation 2D sine theta equal to n lambda. So this is the equation called Bragg's law, which connects the interplanar spacing D and the wavelength of the coming light, the X-ray lambda. What is interplanar spacing here? Interplanar spacing means the spacing between two adjacent planes, D. Lambda is the wavelength of the incident X-ray. So I hope you understood the method of deriving the Bragg's law. Thank you.